I'm Kanishkar from AML department. My mini project is about intrusion detection system for the Internet of Vehicles, where we can find the type of attack that is being attacked on the car. The introduction to the project is you all know that in the recent days or in modern days, every vehicles are integrated with the internet to enable seamless data sharing and smart connectivity for traffic management and safety and enhance the user experience. An intrusion detection system identifies and responds to the unauthorized message or malicious activity on the Internet of Vehicles network, ensuring a safe and the reliable communication. The purpose of the project is that the intrusion detection system that leverages the advanced algorithms to detect the anomalies or to detect the malicious attack that can be done in the real time. The problem statement for the project of the intrusion detection of the system is that the rapidly increasing the connected vehicles has exposed the Internet of Vehicles system to sophisticated cyber attacks, risking the vehicular data, user privacy, and overall network safety. The mobility and constantly changing topology of the Internet of Vehicle networks makes it difficult for traditional intrusion detection systems to identify threats accurately. The objective for this challenge is to develop a real-time intrusion system that accurately identifies and mitigates potential security threats within the Internet of Vehicle networks, ensuring safe, reliable, and uninterrupted communication between the vehicles. The major scope of the project is that the design and the implementation of the Internet of Vehicle intrusion detection system is done using the machine learning models and the deep learning models are used. The real-time threat detection and response ensure that the intrusion detection system can detect and respond to the attacks on the malicious activities that has been done in the car in the real time, addressing the need for the fast action in the high-speed Internet of Vehicles in environment. Anomaly-based detection for unknown threats. Incorporate anomaly-based detection techniques to identify previously known or unknown cyber threats within the IOV systems. User data and user privacy and data security. Protect the user data by incorporating privacy preserving measures to prevent unauthorized access and maintain data integrity. For example, if you take the fuzzy attack, we can we can make sure that the gear position is gear position of the heart rate of the driver can be privately protected. Compliance with the industry security standards aligns the system with the relevant cyber security standards and the regulation for the Internet of Vehicles, enhancing the industry adoption and the user trust. Evaluation of system performance and accuracy. Perform extensive testing to assess the IDS effectiveness, accuracy, and reliability in the real-time environments. Methodology that has been used in my project is that the data collection is the first step, where we collected the gathered data from the Internet of Vehicles, including the traffic patterns, communication logs, potential attack signatures. This data may be simulated from the Internet of Vehicle environments, public data, or the real-world logos to ensure a variety of threat patterns so we can train the model in a better way. Data pre-processing. Clean and pre-process the data to reveal inconsistency, data redundancy, and missing values, etc. Perform feature selection. We focus on the relevant data points that enhances the intrusion detection system models, accuracy, and the performance. Model selection. Suitable deep learning models and machine learning models are used to detect intrusions. The model which I used in my project are the convolutional neural network CNN model, a basic model which is good in detecting patterns in the data, and an exception model, a lighter and efficient model that can work well with the limited amount of resources suitable for all the Internet of Vehicle environments. The VGG19 and the VGG16 models, these are the deep architecture helping the complex patterns in the data and making them effective for more accurate intrusion detection in the Internet of Vehicle environment. SNet uses a unique skip connection technique to improve the learning in the deeper network, which makes it good for identifying the subtle signs of the attack. SNet model. And the methodology used for the intrusion detection system is the model training. Train the each model with the pre-processed data to identify the underlying patterns and pattern both the normal and the intrusion behavior. Use cross-validation and hyperparameter, turning the model accuracy and prevent overfitting to ensure the reliability of the IDS network. Then after the model training, evaluation of the model, evaluate the trained model using the performance metrics such as the accuracy, precision, recall, and F1 score and confusion matrix. Compare model performance to identify the most effective model for the intrusion detection system, ensuring the high detection rates and low false positive values. Prediction and the deployment time. Deploy the chosen model in the IOV network for a real-time inclusion. Monitor traffic, generate alert packets, and update the model regularly to adapt to the new inclusion patterns. The architecture of the inclusion detection system, which have been used with the car. Then we have done several use case diagrams for the UML diagrams and the class diagrams for the project for the inclusion detection system. The sequence diagram which clearly explains the process of the inclusion detection system by a sequence. The algorithms used. First, we have used the data pre-processing algorithms where we are resizing the input image to a standard image size for that is accepted by our machine learning models. For example, 224 into 224 for the VGG and the ResNet, and for 299 into 299 for the exception. Okay. Convolutional neural network CNN algorithms. These layers apply convolutional operations to extract features from the input images. Each model VGG exception ResNet has its own configuration of convolutional. Transfer learning algorithm use the convolution of the pre-trained models to extract features from the input images. Unfreeze some of the top layers of the pre-trained models to adapt the model to a particular task. And the classification algorithms, after feature extraction, a classifier is typically added to make predictions. One or more dense layers that flatten the output from the convolutional base and produce the final classification output. Loss function and the optimization algorithms. Categorical cross entropy is commonly used for multi-class classification tasks. Stochastic gradient descent is a widely used optimization algorithm for training neural networks. Evolution algorithms. After training the model, evolution methods are employed to assess its performance. The ratio of correctly predicted instance to the total instance. Precision recall and F1 score are the metrics that provide insight into the model performance, especially in imbalanced dataset. Deployment algorithms. Real-time interference or inference or algorithms that allow the model to make predictions on incoming data streams. Feedback loop is a mechanism to continuously collect data and improve the model based on new patterns or anomalies detected in the field. The hardware and the software selection for the intrusion detection processes. The hardware environment processor of Intel Core i5 or higher, and the hard disk of approximately 500 GB SSD, RAM about 18 GB, graphics card, and keyboard. Software deployment is about a Windows 10 or 11 or a Ubuntu or Mac OS. Languages used in the project is Python, and Jupyter Notebook is also used. Implementation. Vehicle layer data collection and collect data from the vehicle and perform lightweight onboard anomaly detection using rule-based or simple machine learning methods. Vehicle layer communication transmits detected anomalies or aggregated data to edge nodes or the cloud using MQTT or HTTP for further analysis. Then important core segments of the project is given below. Import all the necessary libraries of the Python and pre-process the data so that it can be easily accepted by the models, and then build each model like the CNN model, exception model, VGG19 model, VGG16 model, and ResNet model. Then load all the model into one and generate load all the model into one and generate a meta model to ensemble the model so we can get the concatenation of the model to get the better results. And the output is given as the images as we are changing the CSV file into the image. The accuracy of the machine learning model which we performed for the intrusion detection, the accuracy is 90%, 95%, and the precision is 94%, and the recall is 25%. And the SDG goals for the intrusion detection system is SDG 9, Industry, Innovation, and Infrastructure. Developing an intrusion detection system enhances the security, resilience of intelligent transportation systems and IoV networks, promoting sustainable industrial innovation. SDG 11 Sustainable Cities and Communities. Securing Internet of Vehicles helps create safer, more reliable smart city ecosystem and enhances urban mobility while protecting critical infrastructure. SDG 13 Efficient and secure IoV systems can optimize traffic flow and reduce fuel consumption, indirectly contributing to lower carbon emission and mitigating the climate change. Conclusion. The conclusion of the project, the intrusion detection system strengthens the Internet of Vehicle security by effectively detecting and mitigating cyber threats in real time. Advanced machine learning and anomaly detection techniques ensure high accuracy while reducing false positive. Advancing IoV IDS with machine learning ensures better threat detection, adapting to evolving attack patterns efficiently. This project enhances IoV resilience, laying a foundation for secure, autonomous, and cooperative vehicle networks. Privacy-centered real-time idea systems offer essential protection and adaptability in IoV's increasingly connected environment. The future work is that a intrusion detection system with AI-driven threat prediction models can proactive defense in the Internet of Vehicle networks, expand scalability to accommodate a larger Internet of Vehicle ecosystem, discuss vehicle communication protocols, enhance system robustness, and continues the updates. Researchers could focus on creating a privacy-preserving adaptive intrusion detection system that can effectively respond to evolving threats into the IoV ecosystem by using federated and transfer learning techniques. The references of the project, the latest one is about the latest one is Lee J. et al.